NCERT Solutions, Class 10, Mathematics, Chapter 1, Exercise 1.1, Question 2. Find the LCM and HCF of the following pairs of integers and verify that LCM times HCF is equal to product of the two numbers. We are given three problems. The first one is 26 and 91. The second problem is 510 and 92. Third problem is 336 and 54. Answer. To find the HCF and LCM, we will use the prime factorization. We first write each number in their prime factorization form. Consider that we have written each number as the product of its prime factors. What is the HCF? HCF is highest common factor, which is the product of all the common prime factors with the smallest power. Then what is the LCM? Least common multiple is the product of all prime factors that appear in any of the two numbers using the highest power. And after that we verify that LCM times HCF of the given two numbers is equal to the product of the two numbers. The first problem, we are given a pair of numbers 26 and 91. Now let us start the prime factorization of 26. Start with the prime number 2. Since 26 is an even number, it is divisible by 2. Therefore 26 divided by 2 is 13. Now we have 13. Since 13 is already a prime number, we can stop the prime factorization for 26. Therefore 26 is equal to 2 times 13. Now let us do the prime factorization for 91. Let us start with the prime number 2. Since 91 ends with an odd number, it is not divisible by 2. Now let us move to the next prime number 3. The sum of the digits in 91, which is 9 plus 1 is equal to 10, is not divisible by 3. Therefore 91 is not divisible by 3. Now let us move to the next prime number 5. Since 91 ends with neither 5 nor 0, it is not divisible by 5. So let us move to the next prime number 7. 91 divided by 7 is equal to 3. It is 13. And 13 is already a prime number. So 91 is equal to 7 times 13. So now we have 26 and 91 written as the product of their prime factors. 26 is equal to 2 times 13 and 91 is equal to 7 times 13. Now let us find the HCF and LCM. What is HCF? HCF is the product of all common prime factors with the smallest power. In 26 and 91, what are the common prime factors? 13. And the least power is 1. HCF of 26 and 91 is equal to 13. Now let us find the LCM. What is LCM? LCM is the product of all prime factors that appear in any of the numbers using the highest power. For 26 and 91, we have 2, 7 and 13 prime factors. Therefore LCM can be written as 2 times 7 times 13. And the highest power of 2, 7 and 13 in both the numbers is 1, 1 and 1 respectively. Therefore LCM can be written as 2 power 1 into 7 power 1 into 13 power 1, which is equal to 182. 2 times 7 is 14 and 14 times 13 is 182. Now let us do the verification of the statement. LCM times HCF is equal to product of the two numbers. What is LCM? LCM is 182 and HCF is 13. And the product of the numbers is 26 times 91. 182 times 13 is 2366 and 26 times 91 is 2366. Therefore, we can verify that LCM times HCF is equal to product of the two numbers for the given two numbers 26 and 91. In the second problem, we are given the pair of numbers 510 and 92. Now let us start the prime factorization for 510. Check the divisibility by 2. Since 510 ends with an even number, 510 is divisible by 2. Divide 510 by 2, which gives us 255. Now we have 255. Since the last digit is 5, which is not divisible by 2, therefore 255 is not divisible by 2. Next, check with the prime number 3. The sum of the digits 2 plus 5 is equal to 12, which is divisible by 3. Therefore, 255 is divisible by 3. 255 divided by 3 is equal to 85. Now we have 85. Check the divisibility of 85 by 3. The sum of the digits 8 plus 5 is equal to 13, not divisible by 3. Therefore, 85 is not divisible by 3. Now let us move to the next prime number 5. Since 85 ends with 5, it is divisible by 5. Divide 85 by 5. We get 17. And 17 is already a prime number. Therefore, we can stop the prime factorization of 510. 510 is equal to 2 times 3 times 5 times 17. Now let us do the prime factorization of 92. Check divisibility by 2. Since 92 ends with an even number, it is divisible by 2. Divide 92 by 2. 4 and 6. 92 divided by 2 is equal to 46. Now we have 46. Check the divisibility by 2. 6 is an even number. Therefore, 46 is divisible by 2. Divide 46 by 2. We get 23. Now we have 23. 23 is already a prime number. Therefore, so we can stop the prime factorization of 92. Therefore, we have 92 is equal to 2 times 2 times 23, which can be written as 2 square 23. We have completed the prime factorization for the given two numbers. 510 is equal to 2 power 1 into 3 power 1 into 5 power 1 into 17. And we have 92 is equal to 2 square into 23. Now we shall find the HCF and LCM. Apply the definition of HCF. HCF is the product of all the common prime factors with the smallest power. And what are the common factors that we have for 92 and 510? We have 2. And what is the lowest power of 2? It is a minimum of 1 and 2, which is 1. Therefore, HCF of 510 and 92 is equal to 2 power 1, which is equal to 2. Now let us find the LCM. Let us write down all the primes that we have. 2, 3, 5, 17 and 23. Now the highest power of 2 in both 92 and 510 is 2. Therefore we can write 2 square times the highest power of 3 in both the numbers is 1. Therefore into 3 power 1, and the highest power of 5 we have is 1. Therefore into 5 power 1, and for 17 we have the highest power as 1. Therefore into 17, and for 23 we have the highest power of 1. Therefore into 23. Therefore LCM is equal to 2 square into 3 into 5 into 17 into 23, which is equal to 23460. Now let us do the verification. LCM times HCF should be equal to product of the two numbers. Now what is the LCM times HCF? 23460 times 2, which is equal to 46920. Now let us find the product of the two numbers. 510 times 92, which is also equal to 46920. Therefore we have verified that the product of LCM and HCF of the two numbers 510 and 92 is equal to the product of the two numbers 510 and 92. In the third problem, the given pair of numbers is 336 and 54. Now let us do the prime factorization of these two numbers and find their LCM and HCF. Start the prime factorization for 336. Check divisibility by 2. Since 336 ends with an even number, 336 is divisible by 2. Divide 336 by 2. We get 168. Now we have 168. Since 168 ends with an even number, it is divisible by 2. Divide 168 by 2. We get 84. Now we have 84. Check divisibility by 2. Since 84 ends with an even number, it is divisible by 2. 84 divided by 2 is equal to 42. 42 is also an even number. Therefore it is also divisible by 2. 42 divided by 2 is equal to 21. 21 is not an even number. Therefore it is not divisible by 2 anymore. Now check divisibility by next prime number 3. 2 plus 1 is equal to 3. 21 is divisible by 3. Divide 21 by 3. We get 7. 7 is already a prime number. Therefore we can stop the prime factorization of 336. 336 is equal to 2 times 2 times 2 times 2 times 3 times 7. All the 2's can be written as 2 power 4. And we have 3 times 7. Therefore 336 is equal to 2 power 4 into 3 into 7. Now let us do the prime factorization of 54. Start checking the divisibility by the first prime number 2. 54 is an even number, therefore it is divisible by 2. 54 divided by 2 is equal to 27. Now we have 27. Since 27 is not an even number, it is not divisible by 2. We now check with the next prime number 3. 27, sum of digits in 27 is equal to 2 plus 7, which is equal to 9, is divisible by 3. Therefore 27 is divisible by 3. Divide 27 by 3. 3 times 9 is 27. Now we have 9. 9 is divisible by 3. Can be written as 3 times 3. Now we have 3. Since 3 is already a prime number, we can stop the prime factorization. Therefore 54 can be written as 2 times 3 times 3 times 3. and this can be written as 2 times 3 power 3. Now we have completed the prime factorization for both the numbers 336 and 54. We have 336 is equal to 2 power 4 into 3 power 1 into 7, and 54 is equal to 2 power 1 into 3 cube. Now let us find the HCF and LCM of these two numbers. HCF is equal to, first write down the common primes, which are 2 and 3. For 2, the smallest power is 1, and for 3, the smallest power is 1. Therefore HCF is equal to 2 times 3, which is equal to 6. Now let us find the LCM. Write down all the primes occurring in both the numbers 2, 3 and 7. What is the highest power for 2? It is 4 from 336. And what is the highest power for 3? It is 3 from 54. And what is the highest power for 7? It is 1 from 336. Therefore LCM is equal to 2 power 4 into 3 power 3 into 7, which is equal to 3024. Now let us do the verification of this statement. The product of LCM and HCF of the given two numbers should be equal to the product of the two numbers. LCM times HCF is equal to 3024 times 6, which is equal to 18144. Now let us do the product of the two numbers, which is 336 into 54, which is equal to 18144. Therefore we have verified that the product of LCM and HCF of given two numbers is equal to their product.